Good evening, everybody. I'm Nitin Kumar, Dev Manager Microsoft, and today my talk is about Siphon. It's a pub subsystem that we have built using Kafka primitives. Agenda for today, I'll talk about the scale at which we operate in Microsoft, and then I'll talk about the use case. We have several use cases. I have picked up one for this talk, and we'll go over that. The motivation behind why we use Kafka and what type of stream processing we do, and what are the services we have built around Kafka that helps us to run this in production system. We'll talk about some of the production experiences and some key takeaways. So, coming to the use case, what is the click-through rate of my ad that launched at 5 p.m.? You get it right. I'm talking about advertiser reporting latency. Meaning, as an advertiser, you bid on keywords to display your ads, and the moment users search for a keyword, the ads are displayed, which is called as an impression. When you click on the ad, it's a click, and this is what we charge advertisers for. And the time it takes when the user makes an impression or click, and then we report it all the way to the advertiser UI, is to be pretty long. It goes through a series of processes across. So I'll just walk you through this. Serving system gets the request, we do some online filtration, and then the entire process is log collected, and we do sorting, partitioning. It is brought to our Cosmos system where the feature extraction works happen. We extract close to 200 features out of every record, and then we do the score machine learning on those. And if you notice, there's a big stat of 25 terabytes, which we hold in memory to do all the joins and computation. And finally, the aggregation happens, it gets reported to DB, and then the advertiser gets to see it. So imagine the advertiser who launched the ad at 5 p.m. not going to wait for 4 hours to view the results. They will come back next day and probably look at the results. So this is the problem we try to solve, to reduce this latency from 4 hours to 15 minutes. With that, we also put together some design consideration that was required for the system. Obviously, the top one was reducing latency from 4 hours to 15 minutes. We wanted a strict guarantee of log completeness because it's a monetization system. We can't tolerate log loss. So that was one of the bigger considerations. Checkpointing fail recovery, meaning if any of the node in the entire system goes down, we want to be replayable without any loss. So we want to keep track of where we exactly lost, and we can pick up right from there. Exactly one semantic, we can't double charge advertisers. So for one impression, we can charge only one. So this consideration has to be there. Highly scalable, available, and rolling upgrades. As you saw from our scale, we wanted to target for something that can grow. As Bing is growing, we expect more and more input data set. So the system has to be scalable. We should be able to upgrade it while it's live. We at any point of time, we can't bring it down. And the most important one is reusing existing C# libraries. Yeah, right. That's what we thought. Putting together all this constraint, we started evaluating a lot of systems. We looked at Storm, Spark, and whatever existed. This is a story 1.5 years ago. So we looked at everything around and zeroed it into Kafka and stream scope. So Kafka we used as a distributed queue where we can buffer our data from data centers. And then we use stream scope, which is a distributed processing system built inside Microsoft, and that runs on Cosmos, our HDFS type of system. So with this, we were able to reduce the latency to less than 15 minutes. And today's talk is mainly about the Siphon data bus, everything that we did around Kafka to make it run in production and make it useful for us.
For big data streaming processing, a typical architecture is to use a message queue system such as Apache Kafka in combination with a streaming data processing system such as Apache Storm Spark Streaming, or Apache Samza. It has become a popular choice to use Kafka for your message queue because of its ability to scale and support high throughput at low latency. For this reason, most of the streaming processing platforms that I mentioned support a native integration with Kafka. Now consider what happens when you bring massive streaming data processing to enterprise data scenarios. What I mean are challenges such as your data sources and destinations may not be co-located. For example, your Kafka queue may not even be on the same network or data center as your streaming processing platform. How do you support high availability and disaster recovery? You need to provide guarantees on data latency and completeness. You also need to provide for privacy and security guarantees. You need to be able to comply with privacy and security guarantees that meet the enterprise standards. At Microsoft, we built such a system. It's called the Siphon Data Bus. It is a distributed pub subsystem that can be used to publish, subscribe, and discover near real-time streams of data, at the same time supporting a scale up to trillions of messages per day. Want to find out more? Come to Strata, New York.